This is section 3.5, power in quadratic models. So again, there's an area up here for you to write your calculator notes. And this will be similar to something that we've done before, just one step different. All right, so if you don't have the note guide, just get a screenshot of this or write this down real quick, pause the video, because I'm going to flip back over to the calculator. All right, so we need to find the equation of a quadratic function. So we need to find a quadratic regression line. So we've done this before, so you're going to hit your home button. And again, my buttons will turn red. Go to new. It asks you want to save, and you select no. And then we're going to do number 4, add list and spreadsheet. Rename box AX and box BY. Go to your first cell, and we're going to put in our X values. So -4, 2, and 3. And then we put in the corresponding Y values, 89, 17, and 40. Make sure you push enter after you put that last number in. And again, these are ordered pairs. They're points on the graph. So make sure they're paired up correctly. -4 is paired up with 89, 2 and 17, and so forth. From there, you're going to hit menu, go to statistics, stat calculations, and it says it wants a quadratic function. So you want number 6. Now there's quadratic and there's quartic. Don't get those mixed up. You want quadratic. X list we named X. Then you can tab down. Y list we named Y. And nothing else is going to change. And you're going to go down to OK. So you can use the square on your calculator as a mouse pad, or you can tab down and click OK. All right, so it's in the form ax squared plus bx plus c. A is 5, b is -2, and c, let's look at c. Now, if you look in the box, this is close to what? That's just going to be 1. Let's flip back over to the note guide. So the equation is y equals 5x squared minus 2x plus 1. Now, if they know the decimal is going to stop, they don't tell you what to round to. So just be aware of that. But as I mentioned before, they're very specific. They want a quadratic function. They don't try to mix you up. It is there, and it tells you what they want. So this one wants a quadratic function. So let's flip back over. Now you can start over, but what's really nice, if you have the exact same number of points, it's really easy to type over. If it's a different, if you have 4 points instead of 3, it would be easier just to start over. But as we're changing things, you see my numbers are changing over there on the right. So if you do make an error, you can just go in and adjust the number. So our A is 1, our B is -3.5, and our C is -4. And there are some other numbers down here that we're actually going to use in a little bit. Let's go back to the note guide. So y equals, so the first one was a 1x squared. We don't write 1 in front of it, so it's just x squared. The 1 is implied. Minus 3.5x minus 4. So the powers go in descending order. They have the x squared, the x, and then the number without an x attached to it. And that's where the A, B, and C comes in. All right, this one wants a quadratic function. Our points in a different form. We're in a table form. That's fine. So let's go back to the calculator. And since it's not 3 points like we had before, I'm going to start over. I'm going to hit my home button, go to new, and no, I don't want to save what's in there. Then I go to number 4, add list and spreadsheet. I'm going to rename A X and rename B Y. This just makes it easier when we find the regression line. So let's put our X values in. And if you need to, if you're working along, pause this. I'm just going to double check real quick. All right, feeling pretty good. So menu, statistics, stat calculations. And again, it says it wants a quadratic function. So we do quadratic regression. Our X list was X and our Y list was Y. And again, nothing else is going to change. Click OK. All right, so I need to arrow up. So A is 5, B is -4, and I'm going to show you what that e to the -12 is. There you go. So A was 5, so it's 5x squared. Our x term comes next. And then the last one is just the number by itself. We had 1.75 e to the -12. That is 1, 2, 4, 5, 6, 7, 8, 9, 10, 11. That's what that number is. That's pretty much 0. So anytime there's a 0, we don't write that in. We don't write +0. So that's all we're going to do there. Our next one is asking for a power function. So let's start this over. New, we don't want to save. And go to list and spreadsheets. Rename that X, rename that Y. Now I'm going to put all my values in. Be careful with your decimals, take your time. It's always a good idea to kind of just eye things, go back and check. All right, so menu, statistics, stat calculations. This time it's asking for a power function. So if you keep going down, you see power regression. That's the only thing that's different. Our X list is X, our Y list is Y. And again, we don't change anything else. Click OK. So I do need to arrow up a little bit. So let's go to 2 decimal places. 6. All right, and you see the form right here. It's A times X raised to the power of B. So Y equals, our A was 2.83 X, and the power on X, 0.69. Now, I just said round to 2 decimal places. On the homework, it's probably going to be 1 or 2 decimal places, sometimes 3. It just depends on the question. So read to see how many decimal places they want you to round to. Let's look at a few more. All right, so this one wants, let's look at this, a power function and linear function, and then determine which one is a better fit. Okay, so let's go here. So we're just going to start this all over. So new, we don't want to save. Add list and spreadsheet. Rename these X and Y. And if you need a minute, just pause this to put your numbers in. First one they ask for is a power function. So I'm going to go through here. Power regression. Click OK. And let's use 2 decimal places. And a number we need to write down is r squared. It's right here. All right. So let's write the equation first. A is 4.12, x raised to the 1.24. So down here on the side somewhere, they don't ask you to use the r squared values. I use them because they are the most accurate way to tell which one's the better model. So make sure you label them. Okay. And take that r squared value out to 4 decimal places. I've worked these. 3 doesn't always work, so use 4. So let's go back to the calculator. The second they ask for is a linear model. So you don't have to start over. Just hit menu, statistics, stat calculations. And again, we're always going to use the first linear regression. X list, Y list, and click OK. And again, I'm going to use 2 decimal places. And just make a note of the r squared value, not the r, but the r squared. All right, so this is linear, so y equals 7.86x minus 6.67. And that r squared value was 0.9639. All right, so those are 2 really, really good models. The closer it is to 1, the better model it is. Again, anything like from 0.85, even 0.8 to 1 is a good model. If you were to look at these, it would be very hard to tell the difference between the two, but whichever number is bigger is your better model. So that's the most accurate way to determine which one is the better model. All right, let's look. We want to power or linear and determine which one's a better model. It's a smaller set of data, and just with all this information here, it's always best just to start it over so it doesn't get confusing. So new, we don't want to save that. And I'll go through this a little bit quicker. Always pause it if you need to. All right, again, first one's a power. So menu, statistics, stat calculations, put a power regression. Click OK. Again, I'm going to feel better with 2 decimal places. Just make sure to see what they ask. I'm going to write that r squared value down. So 9995. They also ask for a linear model. So I'm going to go ahead and run that. Menu, statistics, stat calculations, first linear regression, X and Y, and click OK. So 2.04 and minus 1.29. And that R squared is 1. All right, so you see we have linear power, all this information's here. Let's go back and fill this in. So our power model was y equals 1.40x raised to the power of 1.14. The linear was y equals 2.04x minus 1.29. And let's look at our R squared values. Make sure you label them off to the side somewhere so you know which one goes with which. And always take it out to 4 decimal places. These are both excellent models. I wouldn't even say there's really any difference here. And this is why you need to go out to 4 decimal places, because if I only took this one out to 3, I wouldn't be able to compare them. So the one with the 5 on the end instead of the 2 is just slightly bigger. Honestly, they would be almost exactly the same. You wouldn't be able to visually tell them apart. So now we're going to deal with a word problem. The table gives a country's gross domestic product in trillions of dollars for selected years 2005 and projected to 2070. So let's go down. Find the best fitting quadratic model. So this one's asking for a quadratic model. Find the power model that is the best fit for the data. We're just kind of previewing. And compare the two models. So which one is the better fit? So you're going to need to look at the R squared values. So count 1 for quadratic. You're going to have 1 for a power model. Now on both of these, part A and B says X is equal to the number of years after 2000. So we don't use the actual year itself. So for 2005, how many years after 2000 is that? 5, 10, 15, and so forth. All right, 30. This is going over, looks like 3. And they just place it like this for the sake of space so you don't have these super long columns. But it's just one set of data. So instead of the actual years, we're going to use a modified X value. At this point, I'm going to flip over to the calculator. If you need to, you can pause this at any point. All right, I have a bunch of nonsense from the last problem, so I do want to start this over just for the sake of it not being so confusing. Same process as before. Be careful typing in the X and Y's. And I'm going to go back up here and double check my decimals. Oops. All right. So the first one was a quadratic model. So, oops. Can't see anything. That's because my list was so long. So I need to arrow up. Here we go. And it did say it wanted 3 decimal places. And that R squared value is 9878. And then it also wanted a power model. Power's down here. Right. Also 3 decimal places. This point, I'm going to put back over to the note guide. All right, so for a quadratic model, starts with x squared. So ax squared plus bx plus c. And then our power model, we have a times x raised to the 1.342. All right, so for our quadratic, our r squared was 0.9878, and our power model was 0.8927. Which one's bigger? The quadratic is, so this one is the better model. And that is the end of section 3.5.